Dear students, let us learn today a little bit of deBroglie matter waves. De Broglie had suggested that every moving particle has wave properties associated with it. Until now, we understood that matter has basically a corpuscular nature, that is, matter comes in the form of particles. But by this study, we could realize that matter exhibits dual properties of particle nature as well as wave nature. So, how can you simply understand that? So, first, let us write the sentence that every moving particle has wave properties associated with it. These waves are called as matter waves or de Broglie waves because de Broglie had given this idea. Now let me tell you a simple thing. All of you are aware of Young's double slit experiment, isn't it? So these are the two slits which were illuminated by a light source kept at a finite distance, and on the screen you were getting the interference pattern of bright and dark spots which used to come into existence because of the constructive and destructive interference of these wave fronts which were passing through these slits. Now if we replace this source of light by some gun diode, that means a source of emission spectra of electrons. Now if electron is hitting this, again on the other side we are getting the interference pattern. That means electrons are interfering in the same way, showing the interference phenomena in the same way as waves. And one more strange thing that we can infer from this is, did the electron pass simultaneously through two slits together? This cannot be true unless the material particle doesn't have wave properties associated with it. So this is one of the examples, one of the instances which proves that the particles have a wave nature as well. Now another experiment of same nature which was conducted to verify the same is Davison-Germer experiment, which you will read a little later. Now today we will first derive the expression for de Broglie matter waves and their wavelength. All of us are aware that we can write the energy of a photon as E is equal to h nu, which is also equal to hc by lambda. We know that photon does not exist at rest, therefore its rest mass is 0. So this is the energy of a photon in that case. Now if the photon is moving, alternately we can write its energy as E equal to mc square. The simple thing is that we will balance these two, equate these two. So mc square is equal to hc by lambda, right? One c will go with this. We are left with mc is equal to h by lambda. So what is this mc? This mc is the momentum of photon, mass into velocity. So p is h by lambda. Or we can write that lambda is h by p. This is in all what we wanted to express. The wavelength of the matter waves or the de Broglie waves associated with any moving particle is h by p, Planck's constant divided by the momentum associated with the particle. Now, some exploitations with respect to the same equations. We know that energy E, kinetic energy by the way, is p square by 2m. So alternatively, we can write p is equal to under root 2me. So in that case, we can choose to write lambda is equal to h by, for p we can write 2me. Now if this particle or this electron has been accelerated by some potential difference of the order ev, E is the charge associated with the electron and V is the potential. If this kinetic energy has been gained as a result of this potential energy, that is this Ek is because of this EV, right? Then for this we can also write it as h by 2mev. Now in case of kinetic energy, we also know that this energy is equal to 3 by 2 kT. From the equipartition law, we know that the energy, total kinetic energy associated with the particle in all the three dimensions is 3 by 2 kT. So for E, we can substitute the same. So lambda is h by under root 2m And for this E, we are going to write 3 by 2 kT. So it is 3 by 2 kT. This 2 goes with this, and lambda is equal to h by 3m kT. I hope you understand that T is the temperature and K is the Boltzmann constant, right? So this is for the purpose of solving numerical problems, that you may be given different kinds of cases for which different formula will be helpful in solving the problems.